Hello everyone. We are discussing chapter 4 of class 10 physics. The topic which we are discussing is moment of a force and equilibrium, and under this topic today we will study about units of moment of force, clockwise and anti-clockwise moments, and some common examples of moment of force. Let us first start with the units of moment of force. The SI unit of moment of force is Newton meter, as moment of force or torque is equal to the product of force and distance. The unit of force is Newton and the unit of distance is meter. So SI unit is Newton meter. Force has gravitational units also, and in gravitational system the SI unit of force is kilogram force. In that case, the SI unit of moment of force will become kgf_m, that is kilogram force meter. When we talk about CGS units, in CGS unit the unit of torque is dyne centimeter. And in gravitational system, the CGS unit of force is gram force. So the CGS unit of torque will be gram force centimeter. Now we have relation between these units. The relation is like how we can present 1 Newton meter into dyne centimeter. 1 Newton is equal to 10 raised to power 5 dyne, and 1 meter is equal to 10 raised to power 2 centimeter. Now bases are same, we have multiplication sign in between, the powers will be added. So 1 Newton meter will become 10 raised to power 7 dyne centimeter. One more relation is there, 1 kilogram force meter is equal to 9.8 Newton meter. And the next relation is 1 gram force centimeter is equal to 980 dyne centimeter. Next is clockwise and anti-clockwise moments. Let's discuss this with the help of this diagram. If I apply force on a body and the force applied by me is turning the body in clockwise direction, that is, if the effect of force on a body is to turn it in clockwise direction, then the moment of that force is known as clockwise moment. And if the effect of force applied on a body is such that it is turning the body in anti-clockwise direction, the moment of that force is known as anti-clockwise moment. Now, the clockwise and anti-clockwise moment of force depends upon two factors. Factor number 1 is point of application of force. Here we have this disc and we are applying force here. When we'll apply force at point A, the disc will start rotating in anti-clockwise direction. And on the same disc, in the same direction, if we will apply the force on point B, the disc will start rotating in clockwise direction. This means that the clockwise or anti-clockwise moment of force depends upon the point of application of force when the force is applied in same direction. And the second case is direction of application of force. In this case, we are applying force in such a way that this body will rotate in anti-clockwise direction, and in this case we are applying force in such a direction that the body will rotate in clockwise direction. So the direction of application of force also decides whether the body will turn anti-clockwise or clockwise. Now there is one very important point which we need to remember, that is clockwise moment of force is always taken as negative and anti-clockwise moment of force is always taken as positive. Now let us discuss some common examples of moment of force. The first example is example of a door. The handle of a door is always provided at its free end. This is the free end of the door and these are the hinges. Right. So the handles of the door are always provided near the free end of the door, as we know that torque is equal to the product of force applied and perpendicular distance of line of action of force from axis of rotation. By providing the handle at the free end of the door, we are increasing the perpendicular distance of line of action of force from axis of rotation so that less force is required to produce the turning effect to open the door. Right? The next example is example of paddles of a cycle. This is the rear wheel of the cycle and this is the front wheel. Right? And this is the foot pedal. This distance is always made large so that to rotate this wheel less effort is required, because as we know that torque is equal to force into perpendicular distance, more will be the perpendicular distance, less force will be required to produce the desired turning effect. Some more examples are: the handle of a hand flour grinder is provided near its rim. The reason is same. By doing so, we are increasing the perpendicular distance of line of action of force from axis of rotation so that less effort is required to turn the hand flour grinder. The next is example of steering wheels of different diameters. This steering wheel has least diameter, this has a little more, and this is having the maximum diameter. The perpendicular distance of axis of rotation and line of action of force is less in this case. It is a little more in this case and it is maximum in this case. So least force will be required to turn this steering wheel. Right? And next is the example of a hand spanner. In case of a hand spanner, its handle is always made long so as to increase the perpendicular distance of line of action of force from axis of rotation. By doing this, we have to apply less force to turn this hand spanner and to open this nut with the help of this. So that's all about our today's video. We'll be continuing our next topics in our next videos. Thank you so much.